here to show the kinds of things that high school students do using the Planting Science platform. I was a teacher who went to one of the workshops about a year ago, and I did this in my classroom, and it has been incredibly successful in getting them engaged and interested in plants in ways that they never thought they would ever do, especially in high school. So I just brought about 4 different projects. A couple of them are kind of similar to show the range of things that students come up with. These are entirely student driven projects. They choose the questions. We have lots of class discussions about questions, what makes a good question. And we go through each step of the scientific process and discuss this as a group. And then they go back to their individual small groups and they discuss things, and they discuss with an online mentor and come up with these projects. A group who wanted to look at sea ferns, but they wanted to look at the effect of density of fern spores on the numbers of males and females. And so they set up multiple plates for each, and they counted lots of gametophytes, and they found some differences, but not huge differences in the numbers of male and female gametophytes. And they wrote it all up in a very nice format. The next project is a group who wanted to study pH levels. They had done a project earlier in the year looking at the effect of pH levels on photosynthesis, and so they decided to extend that to the ferns also. And so the agar is normally at a pH of 6, and they adjusted that up to 8 and then down to 4. And the exciting thing here was that they found really significant differences in the timing of development in the lower pHs. So they got really good results with this. And they were also some of the most enthusiastic about this by the end. At first they were very skeptical, but they did a really beautiful job writing it up, and their conclusions were some of the best in all of my classes. Okay, the third project that I actually had 2 groups do essentially the same project, but they wanted to look at pollutants, and they wanted to look at ammonia. So we used ammonium hydroxide in the agar, which both of these groups found that absolutely no germination occurred with, and they were very frustrated because even their controls didn't work. And so by the end, they were having to explain, well, what do you think is happening here that has prevented anything from germinating at all? Because in the class, everybody else's projects had germinated, at least the controls had, but these hadn't. So this was a really great example for students who think science is just in one side and out the other and everything works perfectly, to see that no, you have to troubleshoot, and then when weird things happen, you have to explain it. So in the end, they did a really good job of error analysis and talking about how they would set things up differently. We had to use very closed environments for these because we were in Arizona and it was unbelievably dry. And so we had put all of the treatment and the controls in the same bag, and we think that there must have been some contamination being in that close proximity. But unfortunately, we ran close to the end of the year and they couldn't explore that further. They really wanted to reset the experiment up again, but time just didn't allow us to do that. So this is just a good overview of the kinds of things that students do, and I thank all of the mentors very much for taking the time to work with these high school students, because they really appreciate it, and it just has opened a whole new world into my classroom.